Hi everybody and welcome. This is Kostas from Credits, and today I will try to explain you how our consensus algorithm is working into our blockchain platform. Okay, in decentralized systems, we must somehow secure the most equitable and democratic way of making decisions. And actually, we are managed to achieve this goal by using our own algorithm. Such kind of algorithms are usually facing problems like how smart, fast, and efficient way they are doing their job. In credits, in our case, the time response is really crucial, and I'm explaining why. Because we are trying to realize 1 million transactions per second being registered into our registry, into our blockchain. To succeed that, we use two other algorithms, and probably a lot of you are familiar with them. And I'm speaking about delegate proof of stake and the Byzantine fault tolerance, usually known as the problem of Byzantine generals. In our system, in order to execute the algorithm, we have created a component. This component, we are calling this component solver. The solver is responsible to organize and execute the algorithm in 9 steps. So let's have a closer view of how these steps are going in process. So let's make a design in our board in order to understand how our blockchain working, and especially how it's working our algorithm. Well, let's have some nodes. This is node 1, this is node 2, this is node 3, node 4, node 5, node 6, node 7, and etc. Node N. So this is our blockchain, all the nodes. In our algorithm, we took a decision in credits that we will run the algorithm in particular rounds, and actually in strictly time frame. So consensus use rounds, and each round has a time limit of 200 milliseconds. So in order to start a new round of our consensus, we know as well from the previous round which was exactly the node who has registered into the blockchain the last block. So we assume from the previous round this node was the node 3. Okay. So if this node was the previous round, from previous round, the registrar. Okay. He is responsible to create a list with all the nodes that we can trust and they can participate to the new round. In order to do that, he is sending a request to all the nodes of our blockchain, and he is expecting to get back the hash they had, the hash of the last block of their local blockchain registry. So, if, as we said, he was the last one, he has the most up-to-date registry, and he must match his registry with the others. So, this is the first step. Actually, after the first step, he is populating a list with all the up-to-date, let's say, n nodes. And we are sure that they have the same exactly registry as he has. Okay, so from this list, from these nodes, he is choosing this one. He is choosing exactly the first fastest node who respond to him. and he's putting this node as a main node. More precisely, all these nodes send their hash. Let's assume that the node number 7, he hasn't up-to-date registry ledger, so he's excluding the number 7. Okay, from the rest nodes he's creating a list. Where's this list? This is time running and this is nodes. Okay, from this list he knows that the first one more fast responded to him. It was, let's assume, the node number 1, this one. So in the second step of our algorithm, this node becomes the main node, and the main node is responsible to organize and run the new consensus round. So the main node, he must create the trust zone with the other nodes. So based on this list, whereas it includes only trusted nodes, he will choose minimum 3 of them and maximum 100. And let's assume that in the second step of our consensus algorithm, he is choosing the number 2, number 4 node, the node 5, node 6. Okay, the main node requests from all the nodes that exist in our blockchain to send him vectors with all their transactions. He's getting all these transactions and he's populating a new list. He's creating a pool of transactions which are candidates to be registered into our blockchain registry. So in the fourth step of our algorithm, the main node, we will calculate all the deltas for each transaction of this population list, and he will distribute to every trust node. Okay, as we said, this is a trust node, this is a trust node, this is a trust node, this is a trust node. In the fourth step phase of our algorithm, when these nodes are getting the list of the deltas, they must validate and verify only these transactions that belong to them. Actually, they must validate the transactions and keep only these transactions that their deltas has positive value. It means that the value is more than 0. Why? Because if it has a 0 value or a negative value, probably they are fake transactions or fraud or something like that. So, step 5. In this step, actually we're starting a second semi-round, let's say, for exchanging information between trusted nodes. Just don't forget to say that the list which is being populated with the transactions and later on is being validated and verified from each trusted node with a positive value of deltas. In this list, we're excluding the list of transactions that maybe has the main node. So if the main node has his own transactions list, a vector, for example, he will not include it in this list. he will keep it in a queue in order to be executed in a second in the next round. So, in order to start the fifth phase, the fifth step, our consensus algorithm, he needs this verified and validated list with the positive deltas to take from any trusted node and send it, distribute it to each other. So I will try to design a new draw just to understand how is this looks like. So in this particular time, we have the node 1 who is acting as a main, and also we have the node, the trusted node 2, we have the trusted node 4, we have the 7, the 5 and the 6. Trusted node 5, trusted node 6. So, except this node, all of these nodes, they have their own validated vector with the transactions. Before starting exchange in between each other, all these files, all these vectors, they have to put their own digital sign. And they start sending everywhere. After each one of these nodes fetching the vectors that all the rest nodes sent to him, they are starting actually the consensus based on the rule of majority. So, in order for each one of these trusted nodes to create the final vector, which we are calling the white list, because there will be only the validated transactions, they are using as well the Byzantine fault tolerance algorithm. So as we said, they are using the Byzantine fault tolerance algorithm, and each node creating the final vector, which includes only the transactions that has a success validated. The rest of transactions, we don't care about them because they are not right transactions, they are not proper transactions. But they are sending the final vector, each one of the nodes, to the main node. And this is already the step number 8. The main node, he is matching all the final vectors from which he has got from all the other nodes, and then also by using the rule of majority, he's going to make a decision which one from these final vector with transactions is a fake one. More precisely, which one of these trusted nodes it's not, forget the word, it's not an honest one. So, in this case, let's assume that from these 4 nodes, the majority matching this final vector, and this final vector. This vector from number 5 node, it's not matching with the others. It's a different one. So the main node, now he's excluding from the candidates nodes that they can write, they can register the new one, last block to our blockchain. He's excluding the number 5. And he said that this node, it was trusted node, but now it's not honest. It's not an honest node. So he doesn't care about him. In this time, he's randomly, I'm speaking about node 1, the main node, this one. He's randomly from the majority and honest nodes, he's choosing one node, and this node is responsible to register to his local database, to his local ledger, the last block. And for example, in our example, we assume that this node, the main node, choose as a registrar the node number 4. So this node, it was a trusted node, and also it's a honest one. And in the last step of our consensus algorithm, this node, he is generating the hash key for the last block. He is registering to his own ledger this block, and he is distributing this block to the rest of all the nodes in system-wide. This is the last step, and after this procedure, this node who becomes as registrar his solver, as we said earlier, the component that is already installed on him, he will start a new round of our consensus algorithm. And we start all over again from the beginning. I hope that I gave you a, let's say, mid-level view of how this is all working. In case that you need more technical information about how all this is working, you can find them into our website in credits.com. Thank you for watching. Have a nice day.